Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. In this video, I will explain to you on the advanced example of the Moivre's theorem. So this question here asking us to solve the equation of root 5 of x minus 1 plus square root of minus 1 equal to 0. So please bear in mind that if we want to solve a solving question like this, actually we want to focusing on solving the x. So what we should do is we need to bring all the other terms here to the other side, and also later on we must get rid of this root 5 here. Okay, so let's do it. First of all, set minus 1 is equal to I. So change this to I. So now we want to bring all of this other term to the other side. Therefore, root 5 of x equal to 1 minus I. So let's solve this root 5 here. So let's take power of 5 to the left hand side and also take power of 5 to the right hand side. Therefore, now we have x equal to 1 minus I to the power of 5. So the algebra of solving x stops here. So what we want to do now is we want to apply the Moivre's theorem to solve 1 minus I to the power of 5. So our first step is we must rename 1 minus I to make our job easy. So let's rename 1 minus I as z. So let z equal to 1 minus I. That is the first step. We want to identify also what is our A and what is our B, because the standard form is A plus BI. Therefore, our A is equal to 1 and our B is equal to minus 1. So that is the first step. The second step, we need to change the Z here to become polar form. Okay, so the polar form later on will be Z equal to R in bracket cos theta plus I sine theta. So why we need to change to polar form? Because in order to apply the Moivre's theorem, it must be in polar form. Okay, so the last step is, since we want to solve x equal to 1 minus I to the power of 5 and we have renamed it into z, so our last step is to apply z to the power of 5. Okay, so in order to find z to the power of 5, this is where the Moivre's theorem comes in. So what is the formula of the Moivre's theorem of power? So from the polar form, z equal to r cos theta plus I sine theta. So when we want to take power of 5, the formula is we take 5 towards our r, take the power of 5, and also we need to multiply 5 towards all of our argument. So the formula of the Moivre's theorem of z to the power of 5 is z equal to r to the power of 5 in bracket cos 5 times our theta plus I sine 5 times theta. Okay, so now let's proceed with step number 1. So first we let z equal to 1 minus I, so we can find our A is equal to 1 and our B is equal to minus 1. That is the first step. The second step, let's change it into polar form. So in order to find a polar form, we'll need two components, which is r and also the argument theta. So let's find r. R is, the formula is the magnitude, so square root A squared plus B squared. Therefore, r is equal to square root 1 squared plus minus 1 squared. So this is square root of 2. So we finish with that. Let's find the argument. So in order to find argument, let's draw first the x-axis and also the y-axis. Okay, and fill in our A and B. Our A is actually the x component, which is which is 1, and B is our y-axis component, which is minus 1. So now it is clear to us that our argument now is in the fourth quadrant. So since we have in the fourth quadrant, we need to find first the reference angle theta bar And then from there, we can find our true argument, which is our theta. Let's find theta power first, the reference angle. The formula is inverse tangent modulus B over A. So let's fill in our B and A. So it is inverse tangent modulus minus 1 over 1, which is inverse tangent 1. So it is 45 degree. If we put it in degree, which is all of you are very comfortable with, it is 45 degree, or if you want to write in radian, it is pi over 4. This is just the reference angle. The true angle is theta equal to 360 degree minus 45 degree. So it is 315 degree. After we find r and argument theta, therefore now we can conclude our polar form. Z is equal to square root of 2 in bracket cos 315 degree plus I sine 315 degree. So we're finished with the second step. So let's do our third step, our last step, which is the Moivre's theorem. Therefore, we want to solve for x, right, which is sec to the power 5 just now. So let's apply the Moivre's theorem here. So from our polar form, square root cos 315 degree plus I sine 315 degree. What we want to do now is we want to apply the Moivre's theorem. So let's take power of 5 at our r and then multiply 5 towards our two arguments. So now our answer becomes square root of 2 to the power of 5 cos 1575 degree plus I sine 1575 degree. Okay, this is what happened after we calculate it. However, this is not a final answer yet, because the condition for the Moivre's, your argument must be in one cycle. It must be between 0 degree until 360 degree. So what we want to do is we want to change from 1575 here to become in one cycle. So just take a calculator, just punch in 1575, which is minus 360 minus 360 minus 360 until you get the answer within one cycle. So what we'll get later on is 135 degree. So let's rewrite our answer. So our final answer now is square root of 2 to the power of 5 in bracket cos 135 degree plus I sine 135 degree. So this is our final answer if we want to leave our answer here in polar form. However, if the question wants you to give the answer in standard form, just take your calculator, solve cos 135 and solve for sine 135 degree here, and then you just multiply square root of 25 towards your first term, and then just multiply again towards the second term, and then don't forget to write this term here plus I. So if you use your calculator later on, you will find out that this answer is minus 4 plus 4i. Okay, that's all. Thank you. Assalamualaikum warahmatullahi wabarakatuh.